So it's kind of considered to be bad. Well, obviously, I think it should be considered bad to directly access instance variables, just like in C++, we tend to make them protected, but there's nothing to stop someone with knowledge of the implementation from going in and directly accessing instance variables. So it's easy to create instances of objects, and that's going to seem a lot like C++ to you. But what's going to be different is how you actually create the classes. First of all, there's no independent class mechanism. Instead, you use Perl's package mechanism to create a class. And you'll normally not have the curly braces that you see there at the top. In this case, the curly braces are there because that class was defined in the same file where I'm creating instances of the class. Typically in Perl, as in C++ and Java, the definition of the class's functions are placed in a separate file from the files that actually use the class. So it would be unusual to have the code for a class in the same file as the code that uses the class. But in this case, I put it all together, and that's why the curly braces are here and at the bottom of the package so that it knows where the class definition began and end. But ordinarily, you don't see these curly braces in the class definition. So instead of class, we see the keyword package. And at the end of that keyword, we see the semicolon. So make sure you put the semicolon there. Also, you'll use package rather than class because we're using Perl's package mechanism. The constructors can be named anything you want, but by convention, they're named new so that they correspond to what's done in C++. You cannot overload new. In C++ and Java, you're allowed to overload the name of the constructor. You can't do that in Perl. You get one name. However, you are allowed to create multiple constructors in Perl as long as you give them different names. And when you create an instance of an object, you simply give the name of the constructor. So if I had, instead of naming this new, let's say I had called it make student. So let's say instead of it being sub new, it was sub make student. Then when I create an instance of student, you would see $A equals make student, and then the name of the class, which in this case is student, and then any arguments. So the reason we like to use new as our constructor name is because that means when we make an instance of the class, it looks a lot like C++. However, if we want multiple constructors, we're going to have to give each constructor a different name, and in that case, when you create an instance of the object, you must call the appropriate constructor. And this syntax right here shows you how you do it. It's the name of the constructor, then the name of the package or class, and then the arguments. Whoops. You can't help me with anything. Yes, you can't help me. You're right. Okay. So typically the first thing you do in the constructor is you're going to unpack the argument list into some named variables. And the first argument is always the name of the class. It's a string. And it's provided to you automatically by Perl. It's not an argument that you pass explicitly to the constructor. In fact, when I showed you the call to student, I passed one argument, which was Brad. So Brad is actually going to be unpacked into $name. What gets unpacked into $class is a string called student. And that will be provided automatically for you by Perl, just like C++ and Java provide automatically what variable? Actually, no, not in C++ and different name for it. This. So it gives you as a variable or as a argument this, which you don't have to declare and is a reference to the object. In fact, this string, as you'll see later, can also operate as a virtual pointer to a superclass if we need it. So after you've unpacked it, generally the first thing you're going to do is create the hash table which will store your instance variables. And that hash table should be an anonymous hash table. It should not be a named hash table. So you'll get a reference returned, and typically you assign that hash table, or that reference rather, to a variable named self. And that's just, again, a Perl convention. There's no requirement that the variable be named self, but that's a Perl convention. Self is much like this in C++ and Java. It's a pointer to the so-called object, which in this case is a hash table. Then this bless function, which is very important, is what converts that anonymous hash table into an object. So bless, the bless function, bless, I'm going to put in quotes, converts the hash table. It doesn't convert it really to something else, but it says, it tells, okay, so bless, I'll say it doesn't convert, it tells Perl that the hash table. So bless tells Perl that the hash table will be used as an object. So the first argument is a pointer to the hash table. The second argument is the name of the class it's associated with. So you're saying I'm going to treat this hash table I just created as an instance of $class. So bless, in effect, is saying treat $self as an instance of $class. So the bless command is important. Without it, the whole thing will break down. In fact, the reason Perl knows that this function is a constructor is because of the bless command. So it's really important that you use bless. After you've used bless, you can assign values to your instance variables, and you could have actually said here, I could have used the notation, whoops. I could have used, instead of saying it like this, I could have said $self name equals, so that's what you're used to seeing. The arrow notation is another common way of dereferencing entries in a hash table. On the right-hand side, we're saying that it's equal to either $name if it's defined, or if the user provided no value for $name, name will be undef. Undef is interpreted as false when it is in a Boolean expression. So if $name is undefined, then the OR gets executed. This double pipe is an OR, and it returns, the expression returns the empty string. So in case you missed it in the notes, undef will be cast to an appropriate value depending on the context in which it is used. If undef is being used in a Boolean expression, it will be cast to false. If it is being used in a numeric context, what do you think undef will be converted to? 0. And if it's being used in a string context, for example, if I tried to concatenate something to $name, that was a string, what do you think undef would be converted to? The empty string. So undef can take on different personalities, so to speak, depending on the context in which it's used. In this case, it's being used in the context of a Boolean expression. So if undef is the value of name, it will be false. And finally, it's important to return a pointer to your hash table at the end of the constructor, because if you don't do that, again, it won't work properly. If you have, for example, if you forget the return statement, then the return value of the function is whatever the statement returns, which is not going to be a pointer to the hash table, and the constructor will end up returning not a pointer to the hash table, but a pointer or some value which is not an object. So it's important that you have an explicit return statement that returns a pointer to your object. Okay? So that's your constructor. And you can have as many constructors as you want, provided they all have unique names. And each constructor, there's things that your constructor must do. So important things to do in a constructor. So in a constructor, a Perl constructor, okay, some important things. The first argument is the name of the class. Okay, specifically is a string representing the name of the class. 2, you must create an anonymous hash table and assign it to $self. Now again, that's not required that the variable be named $self, but if you don't do that on a midterm or final, I will take off a point because that's a convention. 3, you must use bless, the bless function, to tell Perl that this hash table should represent an instance of the class. And the final thing is, remember, you must return a pointer. You must return $self. In the constructors for Java and C++, those don't return anything. They're given this pointer. So in Java and C++, when the constructor is entered, the new has already allocated an instance of the object, and you're simply being given a pointer and allowed to modify the object. Therefore, you don't need to return a pointer to the object. But that's not true in Perl. In Perl, you actually must allocate the object in the constructor. Therefore, you must return a pointer to that object. Questions about constructors? Okay. So then, after the constructors, you're going to have your methods. And they look just like functions. So same syntax that you use for functions, you use for methods. And the only difference is that the first parameter that you get is a reference to the hash table for that object. So just like C++ and Java have the implicit this variable that points to the object, Perl appends to the, or actually prepends to your argument list a pointer to the hash table. So a pointer to the hash table will always be your first argument in index location 0. So generally you unpack that hash table again into a variable named $self, after which you're free to manipulate that hash table in any way you see fit. In this case, getName simply returns the name attribute. And setName, very similar. We're setting the name. Now we expect an argument in addition to our reference to the hash table, and we set the name field equal to the parameter that was passed in. So it's pretty straightforward writing your methods. The only thing you need to know there is that Perl is prepending a reference to the hash table to your argument list. Okay, so that's what you do to create a class. Now, in general, there's one additional step because you're going to typically put these classes in a separate file. Thus far, you've put your Perl code into classes with what suffix? .pl. When you store a class, it should be stored in a file with a .pm suffix. Stands for Perl module. Also, the file name should be the same as the name of the class. So the file name should be the class name. So in this case, I would put student in a file named student.pm. By convention, the first letter of the class name is capitalized. By convention, the first letter of the class name or of any package name of the package / class is capitalized. That's just a convention. I expect you to use it. Okay, so, but importantly, the file name you use needs to be the same as the class name, which also should make it pretty obvious that you have one class per file. When you do this, you put it in a file, you no longer need to have the curly braces there. But in exchange, you need to add something at the end of the package, which is all packages by convention end with a true statement. So all packages, when they're read, are supposed to return true. And by convention, you do that by putting as your last statement a 1. So by convention, well, not by convention, a true statement must terminate, well, a true statement must be the last statement executed when a module is loaded. Therefore, by convention, we accomplish this. By convention, this is done by putting don't put it in quotes because that will be a string, but I'm putting in quotes here so you know. So by putting a 1 semicolon as your last statement in the file. Yes. That is part of the class declaration. So it's after the last subroutine, okay? Because there's not going to be any, this curly brace, this closing curly brace doesn't exist in a file. It's only there in this case because I'm using it I'm using, after it, I'm having additional code that uses it. Yes, Nick?
So without the curly braces, so do you just do package and then the name at the top of the semicolon? Or
yes.
Okay.
So you start it, so if I was putting this into so I'll actually illustrate. So I'll put this into so if I was actually doing this, I would put this into a file. So I would create a file, I'll call it student.pm. Then I would copy it in, and then the last statement is just 1 colon. Okay, at the top, it's package student. The subs are actually going to be all the way over. And then right after the very last sub, there's a 1 semicolon. There's no final curly brace here to terminate because there's no curly brace at the beginning. Okay. Other questions? Okay, so I think I've pretty much said everything with the special points. So the next thing is you may want to have inheritance. You may want to create subclasses. And to do that, you're still using the package mechanism. So let's say we wanted to create a subclass called Honor Student. To do that, you first of all indicate you have to import the class or classes from which you're inheriting. So Perl supports multiple inheritance, although in general you're going to use single inheritance. So you need to import every class that you're inheriting from. You can use a require statement to do that. That require says this package must be available and loadable. If it fails to load, then Perl will terminate the program with an error message. So the require statement is actually a load. It's loading the code or the .pm file associated with student. Then that doesn't actually say we are a subclass. What says we're a subclass is when we create the ISA array. It's a capitalized ISA for ISA. And it's a comma-separated list of superclasses. Generally, there will only be one, but it could be multiple if you want multiple inheritance. After that, you can go ahead and define your own constructor. In general, you try to use the same name that the superclass used for its constructor, just for consistency. And you typically don't create your own instance of the hash table. Instead, you do that by calling the superclass constructor. This is different than in Java and in C++. In Java and C++, the superclass constructor is automatically called for you before the constructor is executed. But that is not true in scripting languages in general. In scripting languages in general, you must explicitly call the superclass. And in this case, we call the superclass constructor using, this looks odd. Remember I said this was a string. And yet I'm somehow dereferencing it. It works just fine. The Perl interpreter knows how to deal with this. But $class is actually not a reference. It really is a string. And then you use the super keyword followed by the double colon to indicate which of your, well, to indicate you're calling a superclass new method. So the superclass new is going to actually create an instance and presumably return it to you. And then you're adding, in this case, an additional instance variable called awards. And that's a anonymous array because it's square brackets. And then we still must return $self. So in general, we do not create an instance of the hash table in the subclass. Subclasses call the superclass constructor in order to create an instance, or in order to create their hash table and have it blessed. Okay, they don't do it themselves. Now, there is a reason why up in the superclass we did not hard code the name student. So way back up here, at the time that we did the blessing, you might have wondered why not just say bless $self, comma, student. Because you know that the name of the class is student. Hopefully you now see the reason why you don't do that. The reason is that you actually may be creating an instance for a subclass, and the name of that subclass is not student. Notice that the subclass, when it called super, well, it didn't have to pass its name, but when the superclass constructor gets the class name, it will be honor student. It will not be student. So that's why you don't hard code the name of the class in the bless statement, because subclasses may be calling you, in which case the class name will be something other than yourself. Okay? Now, here's something else that's interesting. I'm adding another method called addAward, and you'll see that up here, when I created awards, it was an anonymous array. And you might think that this code, I thought it would work when I first created it. So it seems like I should be able to say push this award, this statement right here, whoops, still not working. So this part right here, it seems, should get a reference to that anonymous array, and then the @ sign right here should cast it to an array. But that's a syntactically invalid construction. Perl will give you a syntax error if you do it. And I've never figured out how to do it. If you try to put a parentheses here to make it clear that the order of operations is to first get the reference and then convert it, you still get an error message. It's into syntax error. So the only way to make it work is to actually first get a reference to the anonymous hash table or the anonymous array and then do the push by doing your cast to an array. So this is just something, this is to push onto an anonymous array is a two-step process. You can't seem to do it directly. You first have to store, you have to retrieve, in this case, the reference from the hash table, store that into a scalar variable, then you can dereference the scalar variable. Okay, and after that, creating a honors student is just like creating any other instance. Now, one thing to know about Perl's inheritance mechanism, let's say that here we're saying print student3 get name. Well, get name was not defined in honor student. That was defined in the superclass. This is where the ISA array comes in. The Perl interpreter will search the ISA array in the exact order in which you present the superclass names. So that said, if Perl cannot find the method name in a class, then it searches the classes in the ISA array in the exact order that they appear. In the ISA array. And it's a depth first search. So if it does not find it in student, it will first, so let's say the ISA array was equal student and say admin for administrator. And let's say student had a superclass named person. If Perl did not find get name in student, it would then go up to person. It would not do a breadth first search and look at admin next. It does a depth first search through that ISA hierarchy. Yes?
So if you have, does that also work with the constructor if you have multiple superclasses with the same constructor name?
So that is an excellent question. I suspect that if you have so the question for those of you who did not hear it is what happens with the constructor if you have multiple constructor names. And I think it's exactly what you said. It will start, if you have the super keyword, it will look through the ISA list and it will first look at student and it will execute. If new is in student, it will execute there. If it's not in student, it will go up to person. it's not there, it'll go over to admin. So effectively, you select the constructor you want to use. And if you're doing multiple inheritance, you only want to select one of your multiple superclasses because you can only create one hash table. Okay, so you have to make a decision which one's going to do that initialization for you. So questions about subclasses. They would go in a separate file, and this require is what actually imports the student.pm. Okay. Now, the require is a little bulky. It's a two-step process. If you want to simplify it, you can collapse those two statements into a use base. So use base says I'm creating an instance or I'm creating a subclass. The classes I wish to use, in this case, is just student, but you could have a comma-separated list if you were doing multiple inheritance. And this use base will import your superclasses and then set up the ISA array for you. So if you do it this way, you do not have to explicitly use require, and you do not explicitly use the ISA or set up the ISA array. Okay, so are we good with the class mechanism? Okay. So there are uses for modules beyond just having classes. So you often have libraries of functions, like you might have a photography library that does various editing functions on photos. You might decide to have some kind of word processing library. The way you do that is by using Perl's module mechanism. Sometimes also you just want to, on a large project, you want to break the project into different modules to make it easier to manage the project. So there again, you'd be creating a library of functions. You're not creating a class, you're not creating instances. In this case, you're just creating a library of functions. The way you do that is with Perl packages, and you'll hear them referred to as either Perl modules or Perl packages. Those are synonyms. Okay? So you will use the .pm suffix for the file names. Let's actually, again, I think it's easiest to show an example. So you start the module with the name package, the name of the package, and a semicolon. And then actually, every package is a subclass of the exporter class. So you could just say use base exporter here as well. But you must explicitly require the exporter package and then set up the superclass using the ISA array to be exporter. And exporter has two arrays that it knows about. One is called @export and one is called @export_OK. @export is an array that gives the list of default functions to be exported from this package. Export_OK gives a list of additional functions that can be exported from this package, but will only be exported if the user explicitly requests them. So anything in the @export list is automatically imported when you import the module. Export_OK, any function on that list, it's okay to import it, but you must explicitly ask to do so. And the way that you do it is with the use. So when you say use and then a module name, then Perl will import it. You can also say require rather than use. So require is more strict because I believe use will just give you a warning if it can't find the module, whereas require is like die, if it's an error, if the module doesn't exist. So generally you'll see require rather than use. I guess I need to update my notes on that. But at any rate, if you say use or require, Brad, that will import into your namespace all functions on the @export list. If you want to get functions from the export OK list, you have to explicitly mention them. And QW here just stops me from having to put quotes around everything. Don't worry about, I could have also said require Brad, whoops, lowercase Brad, and put it in quotes. QW stands for quote word. What it does is it takes a space delineated list of words and turns them into a comma separated quoted list of words. So that was just me introducing a new function that you will frequently see in Perl code. Once you say the name of an additional function you want to import, it blows away the default list. You don't get the default functions anymore. So if you want to also get the default functions, you have to add then uppercase default. And then you'll import both the default functions plus you will import whatever functions you want from the export OK list. Okay. You'll notice any questions about that. If you have a class, then you also should have use and the class name at the beginning, or require class name at the beginning of your code. So typically you would be using these things in a .pl, but not necessarily. Like in a class.pm module, you're using a base class. So if you want to use a class in a file Perl program, you also need this use or require statement. Okay? So after that, you have, after you've set up the package, after you've set up the ISA and your export lists, then you go ahead and you define your functions. And then you terminate the module with the 1 and the semicolon. So when you load a module, it's actually executable code. For example, this statement actually executes. This statement actually executes. So these arrays actually get created. So when it loads a .pm file, it's actually, the Perl interpreter is actually executing all of those statements, most of which are function declarations. And that's why at the end, you need to have this 1 semicolon, because it will execute as well and returns true. So it's fine to have, just like you have protected functions that are helper functions in a class, it's fine to have functions in that module that aren't going to be exported, that aren't okay to export. Those are just helper functions that you don't expect the user to be able to use. They're not part of the so-called API of your module. So whatever is on the export and export OK, that's effectively the API for that module. Some of you might be wondering, okay, is there a way to make some of my methods in a class be non-accessible? And the answer is no. So all methods in a class are public. You can't hide them. But in a non-class module, you are able to hide some of the functions if you want. Questions about that? Okay, so there is this neat site called Sipan, which is a comprehensive list of Perl resources that has lots of modules that are already out there. For example, for CGI, which is used for doing back-end communication between a client and a server with websites. There are packages, I'm sure, for creating GUIs, for doing photo editing in general. You can find a lot of, well, they have it right here. They're boasting 194,000 Perl modules. So if you're looking for something or if you're thinking of writing your own library, I'd first go to Sipan because there's a good chance what you wanted is already there. Now, just one last thing, because this is pretty cool. I'm not going to test you on this. So everything before now is fair game for testing. This is just something cool that you may find useful at some point, which is editing files from the command line. So let's say that I wanted to change all occurrences of Brad to BVZ in every .html file that I have in a directory. Okay, well, obviously I could go into my favorite editor, and for every file I could laboriously find every occurrence of Brad and replace it with BVZ. Or with this one simple line of Perl, I could cause that same change to be made to all my files. You're thinking, wow, that looks pretty cryptic, and you would be right. So let's go through what's happening here. This should be pretty obvious. It's saying do this for every file that is an HTML file. This also should be pretty clear in what's going on in quotes. Search for every occurrence of Brad, replace it with BVZ. The G says do it if there's more than one occurrence of BVZ on the line. Or I'm sorry, one occurrence of Brad on the line. If I don't have the G, it will only change the first occurrence of Brad on each line. The -E says that's the executable statement in the program. You can have multiple -Es, or you can have multiple commands in the string. Notice there was single quotes. You're allowed to have multiple commands in that string. The -I says to put all of the original files, rename them as .back. So if I had a.html, the original file will still be in the directory when I'm done, and it will be named a.html.back. So the -I is telling Perl to save the original file and put it rename it as .back with a .back suffix. And that's good because if you messed up the command, you'd probably be pretty pissed off to find out that maybe you had irreparably damaged a lot of files. If you don't have the -I, it will not change the files. It will actually dump the changes to standard out. So if you don't have this -I telling Perl where you can put the original files, it won't modify them. Instead, it will print them out, which is a good way to see also whether it's going to work before you actually execute the command for real on the file. So omitting, if you did not have this here, the changes will not actually be made to the files. It will make copies of the files, change the copies, and then print them to standard out. And then the -P sets up what's called a print loop. So the -P option tells Perl to create this so-called print loop. So it creates a little it creates a little program that looks exactly like that while the diamond operator. So it's going to read a line and then print. You're thinking, wait a minute, what's it printing? So there's a special variable in Perl called $_. And if you have not specified where to put the result of reading a line, Perl automatically puts it into $_. And if you do not specify a string or variable to print, it prints whatever is in $_. So this actually is working. The -E stuff is inserted before the print. So whatever is in the -E statement is inserted before the print. And again, it operates if you don't tell it what to operate on. Normally, I would have said something like $A, like that. But since it's not there, it actually is equivalent, that statement is equivalent to saying $_ is set equal to that, is the equivalent statement. And the -I added that line to the file. Okay, so from the command line, you can actually modify content in your files, which is very handy sometimes. If what you want to do is too big to do from the command line, Perl also allows you to create this variable, this $I in your file, and it will do the same thing for you. So you can set up this print loop for yourself. So you could actually write this code into a Perl file, and you could actually say Perl, let's say I named it change.perl, and you could execute it on. So if what you want it to do was too big, you could put this all into your own file and define your own $, $I to set up backup files. So this is pretty cool. I sometimes use this. So you just might want to tuck that away. I won't test you on it, but you may want to tuck it away. And then, let's see. Yep, there's a lot more that you can certainly explore with Perl. We won't do anything more with it in this course. Next week, we will be moving into PHP and JavaScript. So we have 4 weeks left in the course. 2 weeks will be Perl, 2 weeks will be JavaScript. The remaining 4 weeks is actually about creating websites. So PHP is the most commonly used server language on the back end. JavaScript is the most commonly used client-side language. So when you create a page not create a page, but when you're dealing with a website like Amazon or eBay, when you say Amazon, when I say something like Amazon.com, what is on my, oh my gosh, It's not even Thanksgiving. It's one day past Halloween, and we're already into Christmas. It's like Thanksgiving doesn't even get its month anymore. Okay, at any rate, what you see here is JavaScript. When you see this irritating animation, that is JavaScript. Okay, this is something you're not supposed to do with your websites because, well, we'll explain this. Well, I'll just say it now. Because your attention is always drawn to moving objects. So every time that changes, your eye is probably naturally drawn to it, which is what they want. At any rate, this is all being done by JavaScript on my side, on my laptop. Okay, that will be the last 2 weeks of the semester. The next 2 weeks on the Amazon side, most likely they are using PHP to process your requests. So when you send some request to Amazon, like you give them your credit card information or you add something to a shopping cart, on the Amazon side, there's a PHP script that is handling that. So over the next 4 weeks, we're essentially going to be talking about how you create websites. Now, we're not really going to talk about HTML a whole lot, but we are going to talk about how you create the interaction with the user. So with that, I will let you go. Have a nice weekend and get started on homework 7.